We'll start the recording. This is the Math 2460 Zoom meeting. I don't have your names up here, so appreciate y'all coming out early on a Friday morning. Is there anything we can help you with?
I personally
Kind of broke up there. Let me make sure my volume's up. Yeah, my volume's up. Can you say that again? Okay. Oops, saw the names briefly there. Does anybody have any questions about any problems you want to see? I'm not hearing anything. So this means nobody has any questions, or are we having technical difficulties? Can you all hear me? It's like we got two more people. Oh, we'll get in the chat here. Let's see if I can get the chat up. I think my mic is broken. Okay. Yeah, I'm not really used to chatting. In fact, this is the first time I've used it. I didn't even know it was here. I just saw it on the screen. So I'm not really hearing it. I don't know, we're up to 5 more participants now. Does anybody want to say anything?
Can you hear me?
I can hear you now.
Okay, yeah, I think my mic broke for some reason.
Oh.
I was saying I don't think there's any specific problems, but I know we at the end of last Zoom meeting, we were just starting is it 7.3 or 7.2, the second part of this week.
Yeah, 8.3, yeah.
Oh, 8, yeah.
All right, we didn't get to see, there's integrals of tangents and secants, and then there was a third identity called product of sum formulas. You want to see just an example problem out of that off the homework?
Yeah, that works.
All right, well, the general idea is something like 27 here. This is where they give you the involving tangents and secants. They give you a similar set of guidelines, and it's technical enough. I'm not going to write it all down. Here it is. Guidelines for tangents and secants. In the regular classroom, I copy this, of course, give it out, let everybody use it. And of course, I don't have to do that for y'all. Y'all be able to use the book. I can't control that. But you can kind of see there's like 5 cases. And so it's about reading powers of secant and tangent. And first case, secant's even and positive. When it says say the secant square, that means move a secant squared to the end. Convert the remaining factors to tangents. If your power tangent's odd and positive, say that you put a secant tangent toward the end. If there's no factors to the power, the tangent's even and positive. Convert a tangent squared to secant squared, then do this. If you got a secant to a power, you're supposed to use parts. They show you that in example 5 back in A2. And when the first 4 guidelines do not apply, try converting the sines and cosines. Okay, yeah, it's pretty darn technical. Tough to give you every single case. So we'll just give you kind of a general idea of the cases. Why don't we try, if no one has any objection, problem, say 27. This is 8.3, page 538, problem 27. Takes an integral of tan cubed of 2t, secant cubed 2t, dt. One more time. 27. Okay. Just to go back to the guidelines, power of secant even and positive. I don't know if I can get them all on the same page. Power of secant, number 1, even and positive. Oops, doesn't seem to work. Our power of secant is odd. Number 2, power of tangent, odd and positive. Save a secant tangent factor. Okay. That means, so guideline 2 applies. Our power of tangent's odd 3 and it's positive. Save a secant tangent factor. So just like saving a sign on the first set of guidelines, that means move a secant tangent to the end. So I'm going to have a tangent squared of 2t, secant squared of 2t, and it says secant, doesn't matter the order, I guess, secant 2t, tangent 2t dt. And I have saved a secant tangent factor. So in effect, I've split up a tangent cubed to a tan squared and tangent, and a secant cubed to a secant squared and a secant. Convert remaining factors to secants. Convert remaining factors to secants. That would be this. All right. I hope you remember that a tangent squared is a secant squared minus 1. Squared 2t, secant 2t, tangent 2t dt. The logic to this is that these factors you've saved are going to form a du. du on a u du eventually. All right, I guess we should pause for station identification. Have we lost anybody?
What page was it in the book? That chart thing?
This chart is on page 538.
Oh, okay.
535. The homework, this problem's on page 538. The chart's on page 535.
Okay, thank you.
Yeah. Everybody remember a tangent squared is secant squared minus 1, or I need to show you that again? What?
I think that's good.
Okay, 1 plus a tangent squared is secant squared. So a tangent squared, minus 1, minus 1. Tangent squared is a secant squared minus 1. All right, this minus is a signal to bust the integral into 2 pieces. So our first piece is going to be all of this, again, keeping this separate. So we're going to take this secant squared times that secant squared, secant to the 4th. Secant 2t tangent 2t dt. I'm about out of room. I don't know if I can write the rest of it all in one line. Maybe come down with minus, and then all of this times your 1 just doesn't change. Integral secant squared 2t secant 2t tangent 2t dt. We lose anybody doing that? Okay, here's your logic. Now a UDU, both are UDU. UDU integrals. Because the derivative of a secant is a secant tangent. But we are going to have chain rule issues with the 2. So I'm going to make, in this case, call this number 1 and this number 2, say. For number 1, my u will be secant 2t, and du will be secant 2t tangent 2t, because the derivative of secant is secant tangent, times 2, the derivative of 2t dt. You get the same thing over here for number 2. Your u is secant 2t. Derivative is secant 2t, tangent 2t dt. Times 2. Chain rule of 2. I don't know if y'all can see that spyware. I don't know if you all can see that or not. Okay, so can you tell I'm going to have to put in a 2 in both integrals and a 1/2 to fix it. I'll try to write out it one line again before I sub in the u. So I get a 1/2 secant 4th 2t, 2t tangent 2t, 2 dt minus 1/2 integral secant squared 2t, secant 2t, tangent 2t, 2 dt. Have we lost anybody?
I think we're good.
Okay. This is where it starts shortening up because now u, this is a u to the 4th, and du is all that stuff. You got a 1/2. Same thing here. This is a u squared, and all of this is du. I'll go to the next page. One half integral u to the 4th du minus 1/2 integral u squared du. A 1/2 then u to the 5 over 5 minus 1/2 u to the cubed over 3 plus c. You're adding 1 to the power, dividing by that, adding 1, dividing by that. So you're going to get a factor 10 there, factor 6 there. And now you're putting back that u is secant 2t in both cases off the screen. Your u is secant 2t in both cases. So finally, secant to the 5th 2t over 10 minus secant cubed 2t over 6 and c. Questions about that?
So that's like a normal one of these problems?
Yes, and it just,
Oh boy.
yeah, and that's just one guideline. See, if I read another integral, it might say guideline 1 or guideline 3, and you got to do them completely different. Yeah. You see the ramp of difficulty ramping up, and we haven't even hit 8.4 and 8.5 yet. You want to see another example by one of the other guidelines?
Yeah.
Okay, which you want off the homework here?
Yeah, let's see one off the homework.
Let's see. See, they'll mix in something simple to you, even if it does look like random gibberish. 20, if I do point this out, like on 29, so this is back to page 538, an integral secant 6 of 4x tangent of 4x. You really don't need the guidelines at all, and the signal for it is at first power here. If you pull a secant out of this, you get a secant tangent. This will become secant 5th. Make your u your secant, your derivative secant tangent, and you're really there. In other words, if you write this as integral of secant 5th 4x, leaving you a secant 4x tangent 4x dx, you see how you have your u is a secant 4x, and this is your du. Just don't forget a factor of 4 for the chain rule. So they're trying to mix some simple stuff in here, even though It may not look simple. And the signal that it's simple is first power, whereas compared to 31, see how you got secant fifth tangent cubed? We're going to have to pick a guideline out and figure that one out. You want to see this one finished?
Yeah, if you don't mind.
Okay. So your u is secant 4x, your du is secant 4x tangent 4x times 4 dx. I don't know if we can shorten this up. I'll need a 4 and a 1/4. Write it down one more time. 1/4 secant fifth 4x secant 4x tangent 4x 4 dx. So that'll be 1/4 u to the fifth, and all of this is du. Giving you 1/4 u to the 6 over 6 plus c, which will give you secant to the 6 of 4x over 24 plus c. Questions about that?
That one's definitely a lot easier.
Yeah. Yeah, it hardly fits any of the guidelines. I don't know that it fits any guide. Let's see. Power of secant even, and I save as secant squared. You might have worked it by guideline. You might have worked by guideline 1 as well. 33, I think you're going to find works by guideline 5, which is convert to sines and cosines. See, I don't think you're going to find 33 working by the first 4. You want to see something like that?
Yeah, sure.
Okay. If anybody else has anything, please chime in. Am I missing anything on the chat? Anybody want to? No, nobody else? Okay. Anybody else has anything, please chime in. 33. Page 538. Tangent squared over a secant. We're going to try to convert to sines and cosines. So you're going to get an integral sine squared over cosine squared. That's your tangent squared. Secant is 1 over cosine. So you take your top times and flip the bottom. And your 1 cosine cancels. You got to wind up with a sine squared over a cosine. Okay. Let's try converting sine squared to cosine squared. So 1 minus cosine squared. Sine squared is 1 minus cosine squared over cosine. And now I can divide out piece by piece. That'll be an integral 1 over cosine minus cosine. You get 1 over cosine, and then a cosine cancels here, leaving you a cosine. Are we going too fast? We stop for station identification.
Wait, could you explain that step from the dx 1 minus cosine squared x to cosine x to the 1 over cosine x minus cosine x?
Here to here?
Yeah, yeah.
Okay, I'm just distributing the cosine. So with this minus sign, this on bottom distributes.
Oh, and it cancels out the square. Okay, that makes sense.
So then 1 over cosine is a secant. Now, we did this in chapter 5. I don't know if you have these thoroughly memorized or anything, but that worked out a log of a secant plus tangent. Integral of a secant worked out log of secant plus tangent. Chapter 5. And then integral of cosine is sine n plus c. We showed you integral of a secant back then, and integral, I think, is secant cubed as well. Anybody want to see where that is in chapter 5? Y'all have it perfectly memorized like I do? Hearing nothing.
I don't think we need to see that. I'm pretty sure like we could just look back at it.
Okay.
Yeah.
The easiest integrals on the whole page are the very last set, 43 to 47. You just need to plug in trig identities for them and split them up. We're talking about these right here. These are actually the easiest on the whole page. You want an example of one of these?
Sure.
All right, want to try, say, 45?
That works.
Okay. Page 538, problem 45. Integral of a sine 2t cosine 9t dt. Okay. Well, you might think, well, gee, derivative sines of cosine. Yeah, that only worked when the arguments were identical. So they're screwing that up by changing arguments. So you can't make a u a sine of 2t and get a du of a cosine of 9t. Different argument. So the magic secret is the formulas or identities. We're on page 537. I don't know if I need to write them all down, but they should have showed you these in trig, but if you have them memorized from trig, I will bow down. You will be an exceptional student. A product of two sines busts up as a half cosine minus cosine. A product of a sine and a cosine busts up like this. And a product of two cosines with different arguments busts up like this. Again, if you have those memorized from trig, I will bow down. You are a master. I won't write down all three. For this one, we need a product of a sine and a cosine. That's the middle one. All right, don't get confused if you're using x. I'll write it down exactly if I can get it unblurry here. So we need a sine times a cosine. All right. I'll write it down exactly as it's in the book. Okay, a sine of an mx, a sine of an mx times a cosine of an nx goes as a big 1/2 with a big parentheses, sine of an m minus n x plus sine of an m plus n x. Now this might look like the biggest gibberish you ever saw in your life, but trust me, it's not. They're showing the x distributed out, and again, don't get confused because we're using letter t. Adapted to this would read sine of a 2t cosine of a 9t would be a big 1/2, big parentheses. And literally all this just means is you subtract your arguments. You go a sine of your 2t minus 9t. I'm just distributing the t through where you could distribute the, you could write this mx minus nx plus a sine, and you add them. 2t plus 9t. Questions about this? Now you can combine these. So you get a big 1/2 sine of a negative 7t, 2t minus 9t, negative 7t, plus sine 11t. Now you could leave this alone, but I don't like to. I wonder if you remember a basic college algebra, sine is odd. It's an odd function. That means a sine of a negative 7t is a negative sine of 7t. In other words, the negative comes out. If it was even, sine was even, you'd ignore it. Like if it was a cosine. So you can get a 1/2, a negative sine of 7t, add a sine 11t. Should we pause for station identification? Questions about this?
I think I'm good.
Okay, so you just want to replace this in the integral with this. So we're going to plug in the integral. So we get integral then of, I'll put the half in front, a negative sine of 7t, add a sine 11t dt. Now, if you got to write out the UDUs, you're just going to make this even longer. Remember, if you're going to do the antiderivative on your sine, you're going to divide by the 7 and divide by the 11. You get a big 1/2, parentheses. Then you get a cosine of your 7t. It's going to be divided by 7. The derivative of cosine is a negative sine. Times 7, you need the 7 to cancel. And here you are going to need a negative cosine of your 11t divided by 11. Because your derivative of cosine is a negative sine, so you need a negative to cancel it. That's how I argue it out. Anybody want to see the UDUs written out?
Nah.
The book might show the 1/2 out front distributed through. You get a 14 here and a 22 there. Those are intended to be really easy if you know your identities, and again, you'll have access to them in the book. Of course, I gave them to people in the regular class as well. I'm just such a softie, didn't make them memorize them. Getting soft in my old age. That's pretty much examples of everything in 8.2 and 8.3. We're at 30 minutes. Do you want to see anything? Today we've done 8.3. I showed you 8.2 the other day. Did anybody want to see anything again from 8.2? That was about parts.
I think I'm pretty clear on this. So unless anybody else.
Okay. Anybody else want to see any other problems? Happy to hang around as long as y'all want to. Anybody say anything on the chat? No? Okay. We got 6 other people here. Anybody? Next week, we will hit 8.4 and 8.5. We will be on the peak of difficulty for Chapter 8. So we'll be doing both sections and have a quiz over it. So, and WebAssign problems. I'll pre-screen the WebAssign problems. So pretty much a normal week. Next 2 sections, we'll keep the same Zoom schedule. Anybody have anything, say anything, or are we ready to end the meeting? All right, we ready to end the meeting then?
I guess so.
So, all right, we'll see you next week. Hopefully,
Thank you.
Good thing, next Tuesday.